Hello, honors. I know we're going to be diving into an entirely different unit, but it's still a review. So remember, this entire section is like a review of different things between chapter R, chapter 1, and chapter 2. We're just doing an Algebra 1 review, essentially. So we are going into chapter 2 right now. So 2.2, which is graphs of equations. Okay, so graphs of equations. What we're just going to be talking about is a lot of stuff that you guys have already seen in Algebra 1. So it's nothing too wild, but, we kind of dive into some different numbers and some more challenging stuff. So we're just going to start with an example. And that example is going to be to determine if the point rad 3, rad 3 is on the graph given by, hoping you can see, yep, okay, given by the equation x squared plus y squared equals 9. So when we do that, all that you have to do for that is just to plug it in for the point. So I gave it away. I was going to have you guys think about that, but apparently I was getting a little ahead of myself. So to determine if that point rad 3, rad 3 is on our graph, given this equation, without graphing it, all we have to do is just plug it in. We have our x value, we have our y value, and so we can plug in our x here, we can plug in our y here, and see if it comes out to be true. So when it asks this, all we're doing is just plug in the point. I got ahead of myself, and I am sorry for that. So that means into my x value, I know these are the same two values, but bear with me. So in my x value, we're going to plug in rad 3, and we're going to square it. And then we're going to plug in rad 3 for y, because that was also my y value, and then we're going to square it. So rad 3 squared, so rad 3 times rad 3 gets me 3. Or we can just think the square gets rid of the square root. And then plus, same thing here, gets me 3. And so let's see, 3 plus 3 is 6. Does 6 equal 9? And hopefully you're saying, no, Mr. Imperio, it doesn't, because it doesn't. That would be weird. So no. So what does that tell me? Is this a point on our graph? And the answer is no. So when this statement comes out to be false, that tells me that this point is not on the graph. So my answer is rad 3, rad 3 is not on the graph. So that is my answer to number 1. Now, what if it came out to be true? So if, let's say, you did at the end get a statement that said 9 equals 9, is that a true, or that is a true statement? What does that mean? So if you're saying that it is a point on the graph, you would be correct. So if this is false, like 6 doesn't equal 9, then it's not a point on the graph. But if the statement is true, so if you are left with a true statement, the point is on the graph. So if you plug it in and you get a false statement, it's not on the graph. If you plug it in and you get a true statement, it is on the graph. Pretty straightforward. Okay, So now we're going to talk about our intercepts. We're going to talk about our x-intercepts and our y-intercepts. So let's start. Intercepts. Ooh, that feels like the weirdest way. I don't know why, but my writing looks terrible right there. Okay, so let's first start by talking about x-intercepts. Now, x-intercepts, we have 3 other words that we use that are synonyms to x-intercepts. And so maybe you remember them from Algebra 1, maybe you don't. X-intercepts are also known as zeros, solutions, or roots. So we kind of use those words all interchangeably. I know I use those all interchangeably. So it's also known as zeros, solutions, or roots. Okay, so an x-intercept, I'm sure a lot of you guys know the x-intercept is the point where the graph crosses the x-axis. It either crosses it or it touches it. It doesn't always cross through to the other side. Sometimes, like with a quadratic, it just, hits the x-axis and then bounces back. We'll get into that later this year. So the x-intercept is the point where the graph crosses the x-axis. Now, that's great when we're looking at a graph, but let's think about it algebraically. So when we need to solve for an x-intercept, how would we do that? So let's think about that. So when I'm looking at a graph, and I'm going to actually pull up Desmos. If you guys have that app, awesome. It's great. If you don't, download it. I recommend it. It's a great app. It's cool for graphing. So if I have a graph and my equation, I'm just going to do a line. Okay. So my x-intercept is where it crosses, let's make it even, where it crosses the x-axis, right? So that point would be 2, 0. Okay, well, what if I did another one? Y equals 2x, why don't we do instead, plus 6. Okay, so that x-axis or that x-intercept is at 3, 0. Okay, apparently I just did minus, but let's do plus. So y equals, I'm not doing parallel for a reason or any like specific reason, just so you guys can see it better. Okay, so then my x-intercept there is negative 3, 0. So what do all of these x-intercepts have in common, this ordered pair? Negative 3, 0, 2, 0, 3, 0. They all have in common the y value. That y coordinate every single time is 0. And so that's how we're going to solve for our x-intercept. We are going to plug in 0 for the y value and solve for x. Now, that's going to be pretty straightforward when you guys are dealing with lines or, lines. But a lot of times we're going to be dealing with quadratic. So let's talk about that. So when finding the x-intercept of a quadratic, which remember, a quadratic is just something like ax squared plus bx plus c. Set the equation equal to 0, and we solve using 2 methods. So one of the methods is factoring. Remember, when we have a quadratic and we're finding the roots or the solutions or the zeros or the x-intercepts, we are always setting it equal to 0 and hoping that we can factor. But if we can't factor, what is that formula that we use when we cannot factor? And that formula, hopefully you're saying it to yourself, is the quadratic formula. So we are going to talk about that too. Okay, so the x-intercepts, if it's a line, straightforward, plug in 0, solve for, or plug in 0 for y, solve for the x. When it's a quadratic or something of that nature, it's going to be a little bit more tricky. We're going to have to factor, or we're going to have to use the quadratic formula. And we'll do an example with that in a minute. So then let's talk about the y-intercept. So the y-intercept is just the opposite. It's the point where the graph crosses the y-axis. I know, mind-blowing, right? Now, to solve for this, it's just the opposite as the x-intercepts. For the x-intercept, we plug in 0 for the y value and solve for x. For the y-intercept, we plug in 0 for the x value and solve for y. Because if you think about it along the y-intercept, which I can pull up the graph, and we can look at these y-intercepts. So the y-intercept here is 0, -6. The y-intercept there is 0, -4. The y-intercept there is 0, 6. So what they all have in common is that x value of 0. So let's write that. To solve, we plug in 0 for x and solve for y. And the y-intercept is typically pretty straightforward and easy to solve right now in the beginning. Like I can't think of anything that you guys are going to get right now that's anything too complicated. So we are just going to do a few examples here, and then that will be it. So let's do some examples of finding the x and y intercepts. Okay, so for for all of these examples, we are going to, like I said, find the x and y-intercept. Okay, so let's start with, I guess I'll make this 2 since we did one example already. So if I give you f of x equals x squared minus 2x minus 8. Okay, now first, f of x, what do we know f of x is the same as? What variable is f of x the same as? And if you're saying y, you're correct. So remember, this is just the same as y. And if you need to rewrite this as y equals, then by all means, rewrite it as y equals. But a lot of times you'll see it as this. So you just have to get comfortable with knowing that those variables, f of x and y, are interchangeable. So let's start with the x-intercept. So again, going back up here, to solve for the x-intercept, we plug in 0 for y and solve for x. So I'm going to plug in 0 for y and solve for x. Now, this one is kind of my asterisk one here. When finding the x-intercept of a quadratic, this is a quadratic because of that x squared. We set the equation equal to 0, which we did, and we solve by factoring our quadratic formula. So I prefer to first figure out, can I actually factor this? And so that's using my big X. If you don't need to write the big X, then don't write the big X. You don't need to. It doesn't matter. That's not something I'm going to give you points on. But what we are thinking are, what are two numbers that multiply together to get me -8 and add to get me -2? So maybe take some time. If you can't think of those two numbers off the top of your head, pause me here. Think about that on your own. What are those two numbers that multiply together to get me -8 and add to get me -2? And if you're thinking -4 and +2, you would be correct. Now remember, you don't have to split the middle term here because a is equal to 1. So I can just go in and go x minus 4 and x plus 2 equals 0. Now that it's factored and it's set equal to 0, and only when it's set equal to 0, I can set each factor equal to 0 and solve for x. So x minus 4 equals 0, x plus 2 equals 0, and then I just solve. So I would add 4 to both sides, and I get x is equal to 4. And then I would subtract 2 from both sides, and I get x equals negative 2. I'm running out of room. So then when we write that, when we write our answers, I do want you guys to get used to writing those as ordered pairs. So if we plugged in up here, I said plug in 0 for the y value and solve for x, and we got an x value to be 4, one of my x intercepts would be 4, 0. And then my other x-intercept would be negative 2, 0. So every single time you guys are writing your x-intercepts, your y value is always going to be 0. And those are my 2 solutions. Those are my 2 roots. Those are my 2 x-intercepts. However you want to call it, that would be your answer there. Okay, so those are your x-intercepts. Again, remember, x-intercepts are where y is equal to 0. So we have y and we plugged it in. We can solve by factoring and then simplify for x. I do want you guys to write those as ordered pairs, so please make sure you are writing them as ordered pairs. So let's move on to our y-intercept. So for our y-intercept, it's just the opposite. Instead of plugging in 0 for y, we're plugging in 0 for x. So I want you guys to try that on your own, see how you guys do on your own without me explaining that one to you, and then come back and check in to make sure you guys feel comfortable with that. So you should be pausing me now. Okay, so with this one, hopefully you're coming back, you're checking your work. So what I would do is plug in 0 for x. So that's 0 squared minus 2 times 0 minus 8. Well, 0 squared is just 0, minus 2 times 0, which is just 0, minus 8. So 0 minus 0 is 0. 0 minus 8, we get negative 8. Again, I do want you guys to write that as an ordered pair. So if we know that my y is negative 8, we plugged in 0 for x. So my ordered pair would be 0, negative 8. And that would be your answer. Okay, let's go to another example. Okay, I'm going to flip the page. I got lost in my own thoughts there. Okay, so for my next example, so 3, I'm going to give you guys this equation. So we have f of x equals 3x over x squared plus 16. So I want you guys to think about you're finding the x-intercept, and then you're also finding the y-intercept. So what I want you guys to do is just first, with the x-intercept, set it up. What would you plug in for what? How would you get going? Think about that on your own. If you're stuck, unpause the video, come back in, and we can talk about it. Okay. So hopefully you started, and hopefully you know, okay, for the x-intercept, we know that's going to be y equals 0. And so that means, remember, f of x is the same as y. So I'm going to plug in 0 there. And I have 3x over x squared plus 16. Okay, so now when I'm trying to solve for x, we have something in the denominator. I want you guys to think, how would you get rid of that something in the denominator? What would you do to get rid of that denominator? And if you're thinking cross multiply, you would be correct. You're going to be cross multiplying this 0 with that x squared plus 16. And really there's a 1 here, so we're cross multiplying. But really what you're just doing is multiplying both sides by x squared plus 16. So what happens is it cancels here. And what actually happens too on the other side, 0 times x squared plus 16, well, 0 times anything is 0. And now I can set it up to solve for x. So I divide both sides by 3, and I get x equals 0. So my x-intercept here, as an ordered pair, if x is 0, we know y is 0, so my ordered pair here is 0, 0. Okay, so what I want you guys to do is I want you guys to try the y-intercept on your own. So just try that, see how you're doing, and then come back and check to make sure you guys got the same answer as I did. Okay, so we're gonna plug it in. X equals 0. Hopefully you're coming back to check your work. So we just plug it in and solve for y. So 3 times 0, and then 0 squared plus 16. Well, 3 times 0 is 0. 0 squared is 0, and 0 plus 16 is 16. But when the 0's on top, 0 over 16 is 0. Remember, when the 0's on the bottom, that's undefined. But when it's on top, it's 0, so we're good to go. So we write it as an ordered pair. And we already did write it as an ordered pair. They're the same. The origin is my point of intersection for the x-intercept and the y-intercept. So 0, 0 for my y-intercept. Okay. Again, if you guys have any questions going through this, please make sure that you guys are writing them down, asking those questions so you have them ready for class. And then we'll get to the next problem. So we'll go on to number 4.